So Murali, if you can start reading the questions, then it will be nice.
Definitely, sir. If somebody posts the questions, I will
Yes,
read it
sure,
out.
sure, sure. Thank you, Murali. Thank you.
Yes, sir. As of now, nobody has posted, sir, in
Right,
the
right.
form. And then we will wait in Zoom itself. In case if somebody joins, let's ask, sir.
Okay, okay, okay. Thank you. Thank you.
Thank you, sir.
Yes, Mr. Krishnan, we didn't get anyone yet.
No, Amandeep, sir. Nobody has joined Zoom. Also, there are no queries in that Google form also.
Okay.
Yeah, so shall we wait
Okay, I think I'll talk about the general things here. Are you gonna post this video then still live
Yeah.
or not?
Yes, we are live only. We will be posting the recordings. So it's better if you discuss something in general before winding up, Amandeep, sir.
Okay, fine. So
And
in
Go ahead,
general,
Amandeep. Go ahead, Amandeep, so that you can tell all those things. Let
right,
it be a
right.
passive video, right? No problem. Go ahead.
Fine, no issues. So friends, this was a expected to be a live video. We have a few people joining. They might have expected to join. By the time I'll talk about generally about how this rapid manufacturing course is delivered and what all it has covered. Though because we had been pushed hard by the academic community, by the students majorly, since we are here in NPTEL from the year uh, 2018, but in 2000 and I think 19 July session we came up with this course. No, this was started in 2020. Yeah, we came up with this course, rapid manufacturing, when 3D printing had really taken the pace. And it was in big talks that, yeah, 3D printing might completely replace the subtractive manufacturing. So we came up with this course, rapid manufacturing, where we took rapid manufacturing not only from the 3D printing viewpoint, not only from the additive manufacturing viewpoint, we also talked about the rapid manufacturing systems. That is, we talked about the product life cycle management systems as well, but majorly we talked about additive manufacturing. And as it is mentioned in the course, in the introduction slide by Professor Ramkumar itself, this 3D printing has now taken a big pace because we can do complex jobs and complexity kind of comes for free in additive manufacturing. Whatever is or was being manufactured by different 4 or 5 components on a CNC machines, or maybe a 5-axis CNC machines was required to manufacture something which 3D printing can just go in one throw. So this course had 12 weeks, and you have already gone through them. So we had an introduction to the manufacturing in the first week. Then we talked about the general product development process and design for manufacturing, design for assembly, design for maintenance. Everything was discussed in the week 3. So as we come to design for additive manufacturing, in which it was titled as design for modularity, where we compared subtractive and rapid manufacturing technologies. And definitely before manufacturing anything, we need to measure it. And it has a great freedom given by the rapid manufacturing systems that we can just scan and manufacture the things directly from the CAD model based upon what we have gone through the reverse engineering process. So reverse engineering was taken in week 4. Then we had a small laboratory demonstrations on the different kind of reverse engineering setups like coordinate engineering machine. Then we had a hand scanner, the cabinet scanners. Those were taken, and demonstrations are highly appreciated by you all. Thank you so much. Then we talked about the polymerization process. From there itself, the basic science, what is the molecular or the atomic viewpoint when we are talking about the additive manufacturing, that was discussed by Professor Ramkumar. Then he took the powder-based process, the extrusion and liquid-based processes. Then we talked about solid processes such as sheet stacking process and general 3D processing we talked about. Then beam deposition. Then definitely different materials are there in rapid manufacturing, which were also discussed, and post-processing concerns were also taken. After additive manufacturing, maybe of metals, maybe of polymers, post-manufacturing, do we need to have somewhat subtractive manufacturing, somewhat finishing through them, or somewhat heat treatment of the metal parts or so? Then this was added on by or supplemented by the product costing in rapid manufacturing in comparison to subtractive manufacturing. Then CAD, CAE, CAM. Then I talked about the rapid manufacturing systems, where I talked about plant layout and everything. So this course majorly has covered rapid manufacturing from very basic details, basic science behind it, to the overall rapid manufacturing systems. Definitely, After 2020, a lot of new developments have come, and we have even given a new course that was metal additive manufacturing the last semester only. So that also students have appreciated. Regarding this course, I think one of the questions that I could see is regarding the exam pattern. Exam pattern, Professor Ramkumar could tell, or I can also tell, he will add over it, because we both designed the question papers for you. And the question papers would be, the first line or single liner is very similar to what you have taken in the assignment. Definitely, people ask about whether numericals would come or not. Numericals would come, and the basic relations or the small equations that we have given in the course slides, that would be helpful to you. And I would say, definitely, if you have gone through the videos and before the exams, you just go through slides, and somewhat you can refer the books which are there in the reference section of the course. And the books that I have referred are a book by Karmani and Nasir. And then we have Gabbard, then by Gibson, then by Hopkinson, and then by Farm and Demo. These are all books titled as additive manufacturing or rapid manufacturing or design and rapid prototyping or so. So these books you can go through, but basically do not miss anything on the slides. And I can make you sure, if you cover the slides completely and if you have watched the videos carefully, you will be able to get more than 85 or 90% marks, which means you can get then elite certificate from NPTEL. So with the Professor Ramkumar, if you like to add something on it. Any questions by this time? If you have received, Mr. Krishnan, you can just let us know. Maybe on YouTube, maybe here.
So maybe no questions, Amandeep sir.
Okay.
But here one student has joined. He has named as HP. HP, do you have any queries? Can you introduce yourself?
I think he is having some issue in the audio connection, right?
Maybe Amandeep sir.
Yeah, it is trying to connect to audio. HP, I think you can maybe type the question if you have anything in mind. Okay, if nothing is come, we can wait for 1 more minute. And what do you suggest, Mr. Krishnan?
Sure, Amandeep sir. We will wait for 1 or 2 more minutes, and then we will wind up if there are no queries.
Okay.
Thank you, sir. Amandeep sir, there is a question posted in Zoom chat. What is role of EAM in textile industry?
Okay. AL is additive manufacturing. In textile,
I think AL is artificial learning or AM.
The AM he has said, sir, artificial, additive manufacturing, sir.
Sure.
So you can maybe cater this question, sir. In textile, there are certain machines, metal spinning, etc.
Yeah. See, nowadays in textile industry, the raw material which is plastic, now they are trying to bring it in textile form, and polymer also they are trying to make it conducting polymer, absorbing polymer. All those things are coming up. So for prototyping up to TRL3, technology readiness level 3, textile will be very useful. Now we are talking about sweat absorbing socks, non-washable textiles. So for all these things, we need to have trials. So additive manufacturing is going to be customized, and it is going to be the future. Now today you have 32 shirt. If I fall between 32 and 33, there is no shirt for me, or it is a misfit for me. So now what will happen is they will try to measure, they will try to make everything according to that. And a lot of templates have to be made. So additive manufacturing has a huge scope in textile. And rather than embroidery, they are trying to make a 3-dimensional shirt. For example, sweater is a 2.5D. Can we make a 3-dimensional shirt which can withstand both summer and winter just by change of electronic switch? So there are holes where air comes in. You shut it, the hole does not come in. So a lot of new novel things are happening in additive manufacturing. But the polymer, which is there already, is completely changed. It is not only ABS, PET. They are trying to look at new things. In fact, bioprinting textile lever, all these things are now coming up. People are printing for biomedical application, textile in the industry, and again rapid prototyping. They're all blending together. So I'm done.
Wonderful, sir. This was an kind of an eye-opener for me as well, the things, the way you have catered. So HP, I think, and yes, in the textile industry, Professor Ramkumar has already told the way industry is taking the leaps. I'll tell you an interesting case study now it has happened. You know, recently the world event, the World Athletic events has happened in 2023, where, you know, the Shakari Richardson has gone the gold medal, Chris Gale has gone gold medal in 100 meters, because I was also a sprinter, so I was quite interested in watching all those results each night. So there, something has come regarding textile, that two of the runners, two of the athletes who have won in the long run means 3,000 meters. It is his son, and it is for 5,000 meters, the male athlete who has won the thing. They are wearing shoes and the socks manufactured by Nike, which are going to be launched in the year 2024. And somehow people have started talking about that textiles have gone to such an extent that these shoes, which no other athlete was allowed to wear because these were brand ambassadors, has helped them to take some lead. This is a question that is coming. This is the point which we have reached, that additive manufacturing has helped us to create such a prototypes, such a dies for the trials or so, because manufacturing only one set of shoe or two pairs of shoe, maybe 20 pairs of shoe is not a thing. So we can do this regarding the small, or taking the small trials using additive manufacturing. So this is the role of that. Quickly we are able to come up with, it is the basic requirement to rapid manufacturing. That is why it was called rapid. Now because subtractive is being completed, is now called as additive. So it is rapidly or quickly we can get to the results, and we can get the trials of the things. That is the major help that we have got from here. So I think we are clear. So yes, you have given thanks, HP. So anything else, if it is there, Murli, Mr. Murli, see?
No other questions posted, Amandeep sir.
Fine, I think we can call it and next we'll start.
Sure, Amandeep sir. Thank you so much.
Thank you so much.
Ramkumar sir, for this session. Thank you, HP, for joining in. We will end the session now.